our next topic. And yeah, without further ado, Taimur, over to you.
All right. Thank you so much, Raja. Good morning, everyone. My name is Taimur Rashid. I'm part of the AWS team. I lead the Generative AI Innovation Center. We started the Innovation Center about 2.5 years ago, and we are a multidisciplinary team that does forward deployed engineering for customers. And we help them accelerate their journey with Gen AI and Agentic AI, and making sure that they can maximize the value from that investment in the shortest amount of time. I want to thank the Data Science Dojo team for inviting us. I'm really excited to be leading this panel right now, Architecting Scalable Multi-Agent Workflows. And what excites me the most is the group of folks that I have here that are part of the panel. And we have great representation, and I do want to welcome them all over here as well. We have João from Crew AI, Gabriela, and Ali. And I will ask them all to maybe take 1 minute and introduce themselves in that order, and then we'll get into the discussion. So let's start with our gentleman from Crew AI. Yep.
Hey there, everyone. First of all, thank you so much for having me. Taimur, long time no see. I remember we met in Seattle not too long ago. Very excited to be seeing you again, even though it's online.
It's good to see you too.
Well, again, thank you so much. I'm very excited to be here. Thank you so much for the whole folks from Data Science Dojo. Very excited about it. So my name is kind of hard to pronounce. I do go by Joe, and that makes everyone's lives easier. So that is fun. And I'm very excited for a conversation today. If people don't know Crew AI, we basically start an open source tool to help engineers to create AI agents. We still have a project that goes by the same name, and we keep working on that. Very excited to be closing and launching a version 1.0 at some point next month. So let's see how that will go. And then we turned into a company that now is helping many customers across the globe, including the United States Department of Defense, PepsiCo, Royal Bank of Canada, and many others. So very excited to be here.
Well, it's great to have you. Gabriela, did you want to go next?
Yeah, of course. Glad to be here. Great panel. João, or Joe, and I, we are originally from Brazil, so it's great to see like another Brazilian in the panel and all doing agents. It's amazing. So my name is Gabriela de Queiroz. I now have my own company, F02 Labs, where I help startups stand out and scale through AI strategy and developer advocacy. I have worked with over 100 AI startups, helping them go from like this invisible product into recognized leaders within these developer communities, because we know that it's very hard for you to stand out from the crowd, especially now with so many startups. Previously, I was working at Microsoft. I was a director of AI over there, and then at IBM doing AI strategy and innovation. But I also worked at different startups, 3 startups that actually got acquired. And my focus is always helping founders to drive adoption, build visibility, and grow sustainable communities around the product. On the side, I founded 2 global organizations. One is called Our Ladies, and the other one is called AI Inclusive. And together they reach over 200,000 members globally. And the idea is to make technology more inclusive. Very excited to be here and can't wait for our panel and the conversations.
Thank you so much, Gabriela. Really excited to have you. And finally, Ali, did you want to introduce yourself?
Absolutely. Greetings, everyone. Ali Arsanjani. I'm the director for Applied AI Engineering, the Google Cloud AI team. My team leads engagements on the cutting edge of where we're aspiring as a community of people accelerating in agentic AI and trying to make sure that these systems are actually ready for production and to kind of go over the hurdles and speed bumps that we see along the way as we all collectively, as an industry, strive in that direction. The acceleration is very mind-boggling, exciting, and scary at the same time. So I'm very glad we're having these types of panels so that we can share experiences.
Yeah, no, that's great. Thank you so much, Ali, and welcome. What I'm excited about is just getting this really broad and diverse perspective from you all as we look at a few set of topics, right? And so, as multi-agent systems gain traction in the AI landscape, many organizations are experimenting with pilot projects and proof of concepts, very similar to what companies were doing about 2.5 years ago with Gen AI. And clearly with Gen AI, we've made this great progress in the maturity of the tools, the frameworks, the models, right? We're at a very similar point here with multi-agent systems, right? And so as you draw from your diverse experience working with multiple customers and organizations across different sectors, I'd really like to explore initially what are some of those obstacles and also those success stories in scaling multi-agent workflows. So I think a question that I'd like to start off for all the panelists is, what are the biggest barriers that you're seeing with scaling these multi-agent workflows, and for that matter, even building them from the ground up? And are you seeing organizations that are sort of quicker at adopting that and quicker at moving from pilot to production? And so, Joe, maybe we'll start with you first.
Yeah, sure. I mean, that's such a good topic, and I agree with you. It looks like again, it follows a similar pattern that Gen AI, and I would say similar pattern that even other industries in the past. I can find a lot of correlations between this and, for example, data lakes back in the day, where like was a brand new technology, but people don't really understand how to even buy it. So they're trying to understand and navigate these a little bit, but once that they get to value, expansion starts very rapidly. So it's kind of like a similar pattern that we're seeing. Now, it's very much cross vertical and cross horizontal. So we see everything from financial, insurance, CPG. It's across many different industries. I think a few things that I expected to be a little different is I expect to see kind of like SaaS companies moving faster, but a lot of them are going the route of kind of like, oh, let me try build it first, and if I can't build it, then I might look into buy it. Now more bigger enterprise companies are going more into like, no, like I know that I won't be able to build this and keep up with the market pace, so I'd be better off kind of like buy something or partnering with someone that has done this. I'm seeing a lot of interest from highly regulated industry. I think because they are very high regulated, there's like a lot they can automate on their process. They're sad migrating to production is usually a little trickier because of like, again, all the regulations and the environments and all that. But definitely seeing that companies that come in prepared with knowing what they want to build, a very clear understanding of what a success looks like for them, and knowing how to measure usually correlates to success very highly. When companies show up like not being clear and kind of like what they want to do, or maybe they have like a small list of things, but they didn't thought it through, that usually means they have a lot of like homework to do before they actually jumping into the technical side of things. I would say that my quote unquote hot take is the tech is there. I think companies needs to kind of like match a little bit some of the prep work before jumping into them.
Yeah. Yeah, no, that's a fair point. I mean, I echo a lot of that, right? Which is when companies sort of have very intentional things that they want accomplished, right? The success rate in actually productionizing the system gets higher. But naturally, many people are still trying to understand this whole space, right? So, Gabriela, what about from your perspective? What are you seeing?
Yeah, I kind of like see in similar to João, threefold. So the first one is about the operational complexity. So how do we orchestrate multiple agents across tools, APIs, and different data sources in a way that is reliable? It's still immature in several companies and startups. The second piece is around the evaluation trust. So some organizations, they don't have robust ways to measure agent behavior. So correctness and failure modes at scale. That's something that I see very, very often. And then the third one, which is something that we have seen in the industry for like so many years, is the integration debt. So most pilots, they live in these sandbox demos, but when you plug in these agents into the production systems with security, compliance, and monitoring, then it's a different game. Then if we move to the part where I've seen them succeed, it's been when companies treat these multi-agent workflows like software systems, no, not research prototypes. So think about starting small with a high value use case and add observability from day one. And then you create this feedback loop with the users. And the ones that I see that scale also like they build this evaluation so they can iterate safely. And then the other piece that we kind of like forget is the aligning with business. It's so important to align with business very early on. So trying to tie this agent workflow with a clear ROI. This is what like business people and stakeholders, they usually value. It's like, what is the ROI? So this helps with like all the support from executives, stakeholders, and also to get budgets so you can move from pilot to production.
Yeah, no, that's a great point, Gabriela. And it's funny, just the other day, like I've been talking to customers over this past week, and more they're talking about the eval part, the observability end of the spectrum, and what some people are calling AI agent tracing, right? It's just really getting that intelligence about how do agents perform, so ultimately they can drive, a much better outcome through that closed loop, right?
Yeah, and one particular interesting thing is like in the industry we see this loop, this cycle happening over and over and over again. Like when we had like machine learning models, we did all of this already. So now with AI agents, the same thing. Don't forget that we need to evaluate, we need to observe, we need to have like systems in place to make sure that it's doing the thing that it's supposed to do.
Very true. Very true. Yeah. No, thank you so much for that. Ali, and finally, from your perspective, I'd love to hear what you're seeing, and please share that with the group.
Yeah, absolutely. Of course, my colleagues here have shared some keen insights in this area. I think potentially some slightly non-overlapping areas would be that in general, current operational frameworks don't quite have standardized tooling for the entire life cycle of managing interdependent agents that are not just operating individually, but have interdependent actions and dependencies. What this deficit essentially accrues is, or manifests itself in, is the ability to, or rather the inability to effectively monitor agent drift to ensure what we might call non-repudiation with comprehensive audit trails of how an agent to agent, for example, there's a protocol that is now given to the Linux Foundation called the Agent to Agent Interoperability Protocol. Implementing those types of protocols becomes really important because you can have audit trails across companies. Maybe a platform, a specific agentic platform, has their own observability and tools and all that. That's great. But when you have cross-cutting workflows across organizations, it's important to be able to have audit trails, the agentic trails, or rather tracing that you mentioned, Taimur, is basically looking at the agent-to-agent communication and how you transfer information from one agent to another across the organizations. And in that vein, implementing some reliable, auditable, not just agentic interactions, but human-in-the-loop intervention protocols as well. Because the trend towards, okay, we'll have agents do everything. That's kind of a nice objective moonshot example, but we're going to get there in stages. We have to be able to rely on the agents. Maybe send an email reliably, maybe don't mess up the email so I don't get into trouble, right? And once we're okay with that, then okay, but if they want to charge my credit card, they need to come to me. So there's a human in the loop escalation or approval, that sort of thing. So the agentic operations gap, if I can summarize that in one clump, in a category, I would call it the agentic operations gap, where the tooling for lifecycle management of interdependent agents is necessarily not there. The second thing is architectural fragmentation. So pilot deployments generally kind of rely on sequential prompt chaining. Sequential prompt chaining doesn't have the robustness that you would expect for production. So if you want to have scale, you have to adhere to some of the well-known ways of solving these problems. Agentic design patterns like a role-based agent routing, where agents have modularity, they have very specific tasks, they have version tool sets, and their interactions are governed by some formal communication protocol, like the A to A, agent to agent. And Gabriela mentioned another one I was going to mention, which is agentic behavior evaluation. So that's kind of like third on my top priority list.
Yeah. No, that's great. And, Ali, I really like the way you positioned it, because I'd like to build on that conversation, which nicely segues into the next topic, which is when you look at these multi-agent systems, the big thing here is how do they collaborate and how do you coordinate them, right? And so if you had to look at the analogy of just how human capital is deployed within organizations, we think of so many different ways that we can organize teams around certain outcomes, right? And so we've looked at centralized models, we looked at decentralized models, we've actually looked at, how do you mix them both within an organization, right? When you look at multi-agent systems, now you're really not only talking about sort of the technical architecture and all those foundational things that kind of support this multi-agent system, but you also have to think about the operational part that you mentioned as well, too. So could you share from your perspective, what are some trade-offs that builders and companies should think about between, decentralization and centralization in a multi-agent system?
So you have on the one hand, you have kind of what you would consider a centralized orchestration. Some people like to call it a centralized orchestration control plane. So an OCP, a control plane that orchestration is happening. And then you also have a distributed agent execution environment. Agents are interacting between companies via A to A or just randomly, maybe unfortunately, maybe well standardized. So you have the centralized orchestration control plane and you have a distributed agent execution environment. These are kind of two different elements. The functionality of the centralized one, you have the benefits of it is you have global state management, you can control everything from one place, policy and compliance can be enforced, in one location. You can have workflow auditing. You have dynamic resource routing to the best possible tool. And there in the centralized version, your primary architectural objective is centralized governance, accountability, and observability. The trade-off consideration there is, or the potential point of contention maybe that you have to trade off on, if it's not optimized, it requires very complex state serialization in order to make this happen. On the other hand, you have this notion of a distributed agentic execution environment. And in that, task execution, local tool utilization, asynchronous A-to-A communication, and local decision processing are paramount. So the primary architectural objectives you try to get to there are reducing latency because you want things done fast. You can't have people wait for the orchestration to happen. You got to have it local, fast, taking actions being taken and decisions being taken. You want resiliency. So if something has to robustly recover, it can. And to some degree, you want autonomy. So reduction of latency, resiliency, and autonomy are those architectural objectives for the decentralized version. Now, there, the trade-off is you risk emergent, unconstrained behavior. Emergent systems have behavior that emerges without the coordination between the agents because they're not necessarily coordinated, without OCP, the centralized supervision. So the way to balance them is to make sure you understand the architectural objectives. Do you want the centralized, the decentralized? And then try to balance them by ingesting a little bit of the centralized governance over that decentralized area. So at least you have auditability there. And vice versa, the complex state management that's required in the centralized version, you would want to delegate to external agents and tools so that you have a balance.
Yeah. No, that's a fair point. And I do think the way you're characterizing it's very telling, right? Because there are those trade-offs you have to consider, right? There are protocols and standards, which, Gabriela, I wanted to learn from you. you advise so many startups, right? With strategy, with technical guidance and all of that. Are you seeing certain standards or frameworks emerge from your conversations?
Yeah, definitely. So like I've seen all these early building blocks of like the standard for agent orchestration. So frameworks like LangGraph, Crew AI, DSPy, I think that's how you pronounce, are moving us from this ad hoc chaining toward a more like graph-based declarative workflow that are easy to scale and debug. At the same time, I'm seeing protocols such as MCP, A2A, function calling interfaces that are shaping this common language for tool use and interoperability. But in the longer term, when I think about like several years, maybe even months, I believe that this real foundation will combine composability, observability, and governance, giving enterprise the confidence to run these multi-agentic or multi-agent systems in productions, much like what Kubernetes did for containers. And I like thinking about this cloud infrastructure in a way. So like the composability would be like these microservices where we mix and match some modules instead of like rewriting everything. And then the observability, as we mentioned a lot of times here, monitoring and logging, because we need to keep this system reliable. And then the governance, which is like compliance and access control that ensures that you build, whatever you build is not just powerful, but safe and aligned with the business rules.
Yeah. No, that's great. I mean, I like you mentioned, composability, observability, and governance, right? And I do think those are very foundational aspects to it. And I think I like the analogy that you looked at Kubernetes and containers, because in many ways we have heuristics across that world and the world that we're in right now that are very similar, right? And I want to segue to the next question, which is for Joe, which is, in the work that you do with customers, and obviously you have this great platform which gets these, digital workers, which you guys are calling crew or crews. Are there effective strategies that you are seeing as you help customers through that journey?
Yeah, you mean more on the technical side or overall?
More so technical, but feel free to go beyond the tech.
Yeah, I mean, there's definitely a new idea of a stack that has been coming up, right? And if you look into this, it goes all the way back to the data management layer. Like these agents will need to tap into data at some point. So whether that is Databricks, Snowflake, BigQuery, Redshift, whatever you name it, right? It starts all the way back there. And then you have the LLMs. Then you have kind of like the orchestration layer. Then you have like memory, observability, and a few things spread on top. There is authentication, connectors, and I would say on the outmost layer would be this idea of an agentic app, something that you can actually interact with, right? Either conversational or buttons or whatever it might be. But there's definitely idea of this entire stack coming up. And I think people are trying to understand like how much of that stack is grouped together, how much of the stack lives apart from each other, and need to figure it out. So there's definitely a few patterns that we're seeing in there that seems to be working pretty well. I would say that every customer goes to kind of like a 3 phases. There's kind of like an initial phase of building an integration. That is, again, you want to make sure that you get that right. So you want to make sure that you're trying everything, you're setting up things in a way that you can actually monitor them. You're making sure that you have the definition of success that what we called before. And then they go to a second stage where like, all right, this is running. Now I need to make sure that I'm able to observe this and optimize it, right? So it's not only that I want to see traces and what's going on, or even like having this ability to use LLM as judges to highlight or call hallucinations and things like that. But I want to be able to use that to proactively optimize what I'm building. And I want to be able to see that's getting better. And then the final stage would be like the management and kind of like scaling, right? Where like, all right, I care about who gets access to this. I care about what is the scope of permissions. I care that I'm not rebuilding the same agents twice throughout my organization, and that I can run like either 100,000 or 1 million of those, and it's all fine. So I would say those are kind of like the way that most of customers are kind of like thinking about it, and it seems they're having a lot of success with that. It's the way that we have building our entire agent management platform on that as well. This idea of like, hey, needs to be extremely easy to build and integrate this should be extremely powerful to observe and optimize, and managing a scale should like give trust, right? People should be feel that they trust these things can run, like and they can just turn it on to 11. Because what I think like most people don't understand is traces are very interesting and useful, especially when you're developing, right? And allows you to get those things like going and improving very quickly. But once you turn it on to 11, these things are running at machine speed. So it's hard for you to kind of like put your finger on them and monitor them unless you can like set up, as someone else brought up this idea of like automatically in runtime interjecting, rerouting, and all that, right? I'm seeing a new trend of what I'm calling opt-in agency. So I feel like up to this point, or up to like a few months ago, was either people would choose a pattern that is more like, oh, people would push you to graphs, or people would push you to like agents, like completely like using agency. But now what I'm seeing is more like those two getting intertwined, where people might want to have a structure or a backbone where they might do if this, then that, and they have all control that they need. And then in certain steps, they might choose how much agency they want, from a single LLM call to have one single agent to have an entire group of agents working together. And that is a pattern that we are definitely seeing. We call create flows, and I think we're now running 12 million a day of those. So it's insane to see like how this is growing as a pattern for us in like the last like quarter. So
Yeah.
those are some of the things that come to mind.
Yeah, that's really interesting, Joe. Like, is a way to look at that. There's a balance of how do you ensure that the overall system has the right balance of determinism and non-determinism, right?
Yeah, I think it's interesting because the reason why these agents are powerful is because they are probabilistic, right? What it means that they self-heal, you can throw any data at them. If something fails, they're able to like figure it out. So that is interesting. But then people do want to make sure that they get not the same output, but reliable outputs repeatably, right? So that they can trust that. So it's always like you need to strike the right balance of like how much deterministic controls can I add to this probabilistic system. And I think this is the kind of skill that people that have done it like agents and crews before, they developed. But a lot of these companies that have never done this, they need some coaching and training to get there.
Yeah. And you mentioned a few things, like you talked about trust, you talked about permissions, and I think one of the complex things with these multi-agent systems is ensuring that you have the right level of security, privacy, and compliance, right? And while some folks are not necessarily dealing with this right now, over time, as you look at the bigger opportunity, systems have to be very sophisticated in how they manage complex regulatory data, data protection challenges, cross-border considerations, and those kinds of things. And so there is an architectural approach to that. And so Ali, maybe I'll turn this question over to you, is that when you're managing sensitive data in a very distributed agent-based architecture and environment, right? How should builders think about what are the first principles there with multi-agent architectures that have the right security, governance, and compliance built into them?
Yeah, actually, you left the toughest question for me, huh? Just kidding, just kidding.
Well, I know you have a good answer for it.
I sure hope so. What I can do is I can hint on mitigating factors and principles essentially to take into consideration. So I would say that when talking about, I would consider this advanced data security. So what this means when I say advanced data security is kind of like a policy-based agentic data governance. So it's agentic data governance, which is an offshoot, a derivative of general data governance, because agents, these little creatures, can get away and may not be trackable. So you have to govern them through policy. So policy-based data, agentic governance of data. So you need a framework for managing the sensitive data in a distributed agent environment. I would say that there are three principles to take into consideration. One is the principle of least privilege. So in the principle of least privilege, as it sounds, each agent has a unique identity with role-based access control. And then second, access is going to be strictly limited to the data that's essential for the specific role and tools. So when you say this, everybody's like, yeah, that's obvious. No, it isn't. Why isn't it obvious? Because agents tend to have these general LLMs as their brains. So a very generalized, you want to go to a physician who's a very specialized, specialist in, I don't know, skin. When you go to a general practitioner, they know generally what to do about skin, but you need or an ophthalmologist, an eye doctor. You need very specific expertise in that area. So the agents you build have to have brains that are tuned, fine-tuned, LoRa fine-tuned, however, adjusted for that specific task and domain. If they're generalist agents, it's going to be difficult for them to receive the information that's very specific to their role and task and yet deliver non-hallucinatory acceptable outputs. So essentially, when you're limiting data to what's essential for that role and tool, you're preventing unnecessary exposure to sensitive information like PII. So that's principle number one, principle of least privilege. The second one is the abstraction of what we call a context graph. Tokenize and abstract the context graph. So agents don't just pass raw data one to the other. They query a knowledge graph that is very specific for context. So that's a context graph that's tokenized, abstracted, and they share only derived insights. They're not going to send PII back and forth so that they can keep the original data secure. So context graph, the principle number two, context graph abstraction and tokenization. So you're not, just passing around raw data. The third one is basically a kind of compliance. So if an agent has, or data residency controls, let's say in Europe and APAC, let's just say, you have data residency controls like GDPR, CCPA, etc. in specific areas. Agents need to be configured to operate only within their own legal jurisdiction of the data they're processing. So this can be thought of as a principle of cross-jurisdictional compliance. So you're compliant because, yeah, you have 10 agents. Each of the agents are operating in the jurisdiction that they actually are supposed to operate. And just because you have agents, you're not sending data back and forth across these jurisdictions that deny your compliance. So cross-jurisdictional compliance becomes very important. So agents know and operate in their own jurisdiction. So those three, principle of least privilege, context graph abstraction and tokenization, and then this cross-jurisdictional compliance of agents.
Yeah, no, that's great, Ali. I really like those three aspects because they're very foundational. They're first principles, right? Because like you said, this is a very complex thing with all sorts of systems engineering and security engineering that needs to play out here. We've been getting some interesting questions from the group here in the chat, and what I'd like to do is, we have about 13 minutes or so. Some of these questions are very relevant to the conversations that we're having, and so I'd like to bring these questions up and see, Gabriela, Joe, Ali, if any of you feel like you want to answer it, feel free to. One common set of questions that I'm seeing from the group here is how should guardrails be planned for multi-agent systems? And I think to a large extent it relates to the fact that we've been talking about security, governance, compliance, but then Joe, you also mentioned some things around permissions, right? And so maybe I'll throw that out there for the audience, for the panelists to see who would like to answer that question.
Yeah, that's interesting. I think like there's two sorts of guardrails. I would put connectors, tools, apps as a separate topic, but I would say that in terms of guardrails, there's two kinds of guardrails that I have been seeing. One that are less deterministic, that is basically I want to use another LLM to fact check once my agent's done with a specific task before it keeps going. What is definitely one pattern. And the other is people resorting straight to code. Like, hey, I want to get the output of this task, and I want to validate something with actual code. either it's a JSON output, or even if it's a string, and I want to do something with that to validate something. And then depending on the output of that, I want one of two things. I want this to keep going and next agent can take on and can keep going from there. Or I'm going to send this back to the same agent and say like, no, you did this wrong. And this is what you got wrong. So then can keep working and iterating on that. So those are like two patterns that I have seen that people are using a lot. Now there's also, again, to Ali's point, people that are building some of those around PII detection or personal information, depending on kind of like what legislation you're trying to comply with. And then also people doing that to check things prior to the execution. Like make sure that you're checking for prompt injection, a bunch of different other things in there as well. And the prompt injection techniques have been getting very, very sophisticated, I would say. So there's a lot of checks that you can run prior the agent actually take on a request to make sure that you're rolling some of those out. And then the other thing that I also say that we see is like a code generation validation. I think that's another big concern as well. Whenever you have agents that are generating code, like try to make sure that you're sending checking that code for like any kind of like security concerns, and then we're executing that in a way that also is super secure. So in terms of guardrails, those are the kind of guardrails that I'm seeing out there. I don't know if like anyone else would add another kind though.
Yeah, sure.
Yeah,
Ali or
just to-
Gabriela, any thoughts?
Yeah, Gabriela, do you want to go or should I?
You can go first.
Okay, cool. So I can think of, like two levels at least. I know, João, you mentioned them really nicely, but, if you think of them in two levels, you have policy adherence at the high level business level. That's, the business policies, and then agent guardrails at the lower level, authentication, authorization, filtering, PII, etc. So you have these two levels to deal with in terms of essentially auditing compliance and agent policy management. So I think thinking about it in those two levels is helpful because you can enforce them in different ways. For example, if you're using callbacks, for example, in order to monitor and deal with human in the loop, or filtering responses back from a model or back from an agent or back from a tool, you can then, in that callback, you can trap the information and see if it's even, if I should even be able to access that information if I'm calling it. So you have a mechanism to see if the response is adhering to organizational policies. So the very tangible thing I would say is, for example, if you're using something like, you can use Crew AI, of course, or let's say you're using the agent development kit. There are callbacks you can do before and after agent, tool, and model callbacks, where when you're retrieving the information or when you're even sending the information, you can check for policy adherence.
Yeah, no, that's fair. No, thank you so much for that, Ali. One other question that I'm sort of seeing in the chat, it sort of combines a few topics, right? Gabriela, you talked about ROI, and clearly, when you look at multi-agent systems and the investment that's going into deploying these systems, and then eventually over time, them doing a lot of the tasks that typically human beings would do, there's a huge emphasis and a promise around ROI from agentic architectures. And one of the other thoughts that I'm seeing here is that accuracy is going to be so important, right? And so you have generalized agents, which are leveraging, generalized models. And then is there this opportunity where in order to drive higher levels of accuracy and therefore ROI, there's a need to create specialized domain-specific agents, which are then leveraging domain-specific models. And so I think it's a three-pronged question where in order to really get the ROI, there's got to be an investment in higher levels of accuracy with the tasks being done. And sort of how should people think about that and customizing models and building specialized agents? And so I will leave it open for anyone to sort of take that question or just share some thoughts on that.
Yeah, I can talk a little bit about the ROI, because one of the things that I see, it's like, how do I start and which one should I start with, like when building, is I would say, like, think about what is the one that you have a high volume and a very well-defined pain point. So for example, if you have an e-commerce company, probably it's going to be support tickets. And then a way that you can measure clearly. So you have like some metrics in place. There is one example that I want to show about this company, an e-commerce company, where they were able to use like a minimal like infrastructure. They were able to escalate only like 10%, but then they were able to get our ROI very high. I don't remember like what is the number, but it was like very little, but getting a very good ROI. So what I'm saying here is like start small and then build on top once one it's working well.
Yeah, no, that's a fair point. Joe or Ali, any other additional thoughts here? Or we can go to the next question.
Yeah, I think I would second that, but yeah, let's go to the next one. I want to cover as much ground as we can.
Yeah. Okay. No, that sounds good. So, you know, as we're getting closer and closer to the end of our panel discussion here, I'd really like to get each of your thoughts on how should we look at the horizon ahead, right? And so we're at a fascinating inflection point with the evolution of, you know, Gen AI, and now we're at the start of agentic AI, and we're talking multi-agent systems. There's a lot of rapid advancement in foundation models and, you know, various breakthroughs along the way, right? And so the pace of innovation is just moving very, very fast. I'd like to get from each of you, as we look ahead, what are the technological or research breakthroughs do you sort of anticipate that can unlock where we are today and these inflection points that we can have as we go forward? And so, you know, maybe Joe, we'll start with you first.
Yeah, I think like that's a good question, and it's interesting. I think the most interesting thing that I keep thinking about within the industry there, and I go back to my first answer on the panel. I think the tech has come such a long way, and there's a bunch of things that are already kind of working if you string them along correctly. Where I want to see us moving next, and I think like that's where the industry is going to go as well, is how much work these agents can do by themselves. How long these agents can work no stop. I think that's probably where things are going to start to trend a little bit, because that's a very high correlation with how valuable they can be, right? And how much ROI, to Gabriela's point, they can actually bring back. So if you can get these agents doing work for like 1 hour uninterruptedly, that means that you can show a lot of like harder and more complex problems, right? If I say to these agents, like, I don't know, a silly example, but just to highlight, like I said, go over my entire emails that I ever got and classify everything, right? And you don't have to worry about context engineering, you don't have to worry about any of that, and these agents are just able to get it done. I think like that, you start to get in the realm of the possibilities of what you can throw into them that makes them extremely more interesting and more valuable for many of these companies and use cases. So in terms of the horizon, I think there's going to be if I had to pick one thing, I think there's many things, but there's going to be probably ones that I'm very curious to see is how the industry starts to kind of like converge and optimize a little more to how long these agents can run autonomously and how that translates into actual ROI.
Yeah, that's fascinating. Yeah, like the ability for agents to do long range tasks, right? And for what duration? No, that's great. Thank you for that. Ali, what about from you?
I mean, there's a lot of areas, honestly. One area, if I would pick one, is how to balance global optimality with. So when you have an emergent system, you have a multi-agent system that's decentralized. You have emergent behavior, but you need to globally optimize that emergent behavior. So there's a lot of research going into how to do that, how to balance local and global optimization and deal with the emergent behavior in a multi-agent system. So that's number one. Number two, corollary to that would be, as agents become more autonomous, how does that affect that global optimality? And then one, double clicking even further, third level would be multi-agent reinforcement learning, MARL, as you know, people call it, is a way in which you can create reinforcement learning, but with not just one LLM or one agent, but multiple agents. That's a challenge that I think is going to be extremely important. It goes back to the ROI question. It goes back to the OKR question, the metrics question. It kind of engulfs a lot of these things. And I think one person in the audience actually asked a very similar question. And I actually have a blog that kind of talks about the mitigating factors there. And I can point people to that.
That sounds great. No, thank you so much, Ali. And Gabriela, finally, from your perspective.
Yeah, I think there are two things for me. One is when I think about scalability, will come from less from bigger models and more around the infrastructure that we have around them. And then the other piece that I mentioned a lot about was the standardized protocols, which will make easier for agents from different frameworks and vendors to talk each other seamlessly. I don't know what else, but those are the two things that I see coming, like, and being there for a while.
Okay. No, that's great. No, thank you for sharing that. Joe, Ali, and Gabriela, I really want to thank you for your time, your insights, and all that you shared. I really enjoyed the conversation, and we're so early in this journey as an industry that I'm sure we will learn a lot more as we go. So thank you so much for that. I want to thank all the viewers for attending this panel and the Data Science Dojo team for making this possible. So I hope you all have a great day. Thank you so much.
Okay. Thank you all. So before we move on to the next panel, we are going to have about a 15-minute break. So we will come back.